Greetings and welcome, friends. We're here in Vermont, a pleasant snowy day. Lovely, probably an inch or so here in Brattleboro, a couple inches up in the mountains. And we are going over our homework, page 360 dose, talking about adding and subtracting polynomials. And we had a lot of vocabulary in this lesson, so make sure you look that over in case you're a little lost on some of the terminology I have for you. So let's see, it says this: find the degree of the monomial. All right, so the degree in this case is just the 2. It's the exponent of the variables, so the degree is 2. So this, you could say, is a second degree polynomial. There was also another word for it called a quadratic, but that's a weird word. Weird word. What's going on? Quad sounds like 4. How's that 2? Yeah, a quadratic equation will be a second degree polynomial equation. Yep. Let's see. So the degree for this one has 2 variables. However, this t has a little invisible 1 exponent. It was hiding there the whole time. Oh, no. Actually, the degree of the term, you would add it. Yeah, so we would do the 8 plus 1 and get 9. Yeah, so that would be a 9th degree monomial right there. All right, let's see. Write the polynomial in standard form. So once we had this idea of degrees, it has been officially decided by mathematicians to write your polynomial from highest degree to lowest degree. So when I'm looking at, how many terms does this have, by the way? Looks like 3 terms. All right, terms are separated by plus or minus signs. And so this would be a trinomial. Little side note. So yeah, let's order these by degree. So yeah, 2c to the 4th. I agree. Perfect. And what is the degree of that last term there? 1. Question, Michaela? No? For standard form, we go from the biggest to the smallest for degree. So that's what we're doing. So yeah, I just had to swap these two. Yep. And this was a trinomial because it had 3 terms. What is the degree of this polynomial? Right, the degree would be 4. So I could call this a quartic, like quarter. Quartic trinomial, if I wanted. Yeah. All right, let's get to the combining like terms. Get our friends together. Here we go. Find the sum. So combining like terms have the same variables and the same exponents. Have to match perfectly. And to combine them, I add or subtract, respectively, their coefficients. And coefficients were the numbers in front of the term. So the like terms here, let's see, I'm going to use my colors here. So 2n squared. Do I have any other n squared friends here? Yeah, negative n squared. And 2n squared minus 1n squared is just 1n squared, right? 2 apple pies minus an apple pie is 1 apple pie. So it's n squared. You could write a 1 in front of it, but for coefficients, you could just leave that invisible. And that is just fine. How about n to the first terms? Let's see. So, yep. And negative 3n. And if I combine those, nope. Negative 8n. All right. So adding those 2 negative numbers, it's becoming more negative. And 5 plus 3 is 8. Yeah, which we're going to do multiplying today, so hang on to that. Let's see, and I've got to be more consistent with my colors here. I guess I'll just use yellow. Oh, and I've got to do a different shape. Did I? All right, good call. I agree. Yeah, so those are constant terms. and that would be positive 5. So guys, how many terms does my new polynomial have? Right, so this is a 3-term, so it's called a trinomial. The degree, I agree, is 2, right? And so that's a quadratic trinomial. Actually, this might be a great time to explain why a second-degree polynomial is called a quadratic. And it is the case because what type of shape would you call this? This is a rectangle, right? Yeah, it's 4-sided, 4 sides. These can be referred generally to a quadrilateral. All right. And if I had dimensions, say x and 2x, the area of this quadratic would be 2x times x, 2x, and x to the first times x to the first is x squared. And so because the area of quadrilaterals ends up having these squared terms in them, these squared polynomials ended up getting the name quadratic, related to quadrilaterals. But it wasn't the best choice. All right, so I don't know. Let's do a subtraction problem. Where is my scroll bar here? There it is. Ah, see how it's stealthy? Like I have to find it every time. All right, find the difference. Okay, so subtracting polynomials, it's going to be the same idea. I'm going to change this to addition and distribute the minus sign oppositing everybody inside. So if I change this to plus, that means this 12 is now negative. That means this negative 9t squared is now positive, and that this negative 7t is now positive. All right, so the minus sign just opposites everybody. These ones? Well, these ones were not affected by this minus sign. The minus sign was outside this parentheses, so it just got distributed only to the terms inside those parentheses. So let's now just question. What was it? Why? Because these one, like just like if I had like 2 times x plus 1 minus 3, when I distribute, only the people inside the parentheses got multiplied. The minus 3 wouldn't have. Right, so this would have been 2x plus 2 minus 3. Well, the symbols changed only for the polynomial that was actually being subtracted. This one's a positive. Yeah. But let's see, t to the 4th. Are there any other t to the 4ths here? No. So t to the 4th is by itself. Let's see, negative t squared. Do I have any other t squareds? Yeah. A now positive 9t squared. So what's 9t squared minus 1t squared? Yep. And notice the exponents don't change for addition or subtraction. Ooh, I'd love to have some tea right now on this cold winter day. Well, no, the 7t became plus. T. Yep. 8t. And then I've got this minus 12, and I'll just make like a star, I guess. There. Minus 12, and they didn't have any friends. But you're a star, negative 12. You're a star. So there we go. That was the idea of kind of adding and subtracting polynomials and a little bit of vocabulary to become familiar with. All right, thanks for watching. Bye-bye.